Very good afternoon. I am audible? I am audible? I am audible or not?
Yes, ma'am.
Good morning, madam. Good afternoon.
Very good afternoon. What will start today? Chapter 14, I know. 14 point? Which article? 14.1. 14.1, it is over? Tell me. Tell me the question. 14.4. Linearization, I think I already taught to you. Linearization. Huh? See or not? What happened to you? Which article I'll start or not finish any article? So,
Ma'am, we are doing high order derivatives and we have completed till 46th question.
okay, very good. Thank you. Higher order, that is partial derivatives we are doing. 14.3, I think. Mm, 14.3. Answer. You have completed 46, ne? Then after 46, 49.
Yes, ma'am.
Class 12 problem it is 49.
Yes, ma'am.
Okay. I'll tell you next week, but you try to read up to 14.2 because I think it is the common portion in all sections. Okay, up to that you read. If it is more than I say, otherwise read up to that. Okay. 49. Use implicit differentiation. Use implicit differentiation. Write down question to find del z by del x and del z by del y. For the equation, e to the power x is equal to x, y, z. Okay. It is here. Use implicit differentiation to find del z by del x and del z by del y. Here z, you know it is implicit equation. Z is the function of x, y. Okay.
Excuse me, ma'am.
So yes.
Ma'am, it's e with the power of z.
Yes, it is. Sorry, it is z. Sorry, I have written x. It is z. Okay. So here, find out del z by del x. I can write down this is in the implicit form e to the power z minus xyz equal to 0. Already done in example. First differentiate to find out del z by del x. Del z by del x differentiate both sides with respect to x or differentiate it with respect to x. With respect to x. Okay, keeping y as constant. Only y as constant, not z, because z is the function of xy. Constant. So what you get? It is del by del x of e to the power z. Okay, then minus it is your del by del x of x y z equal to 0. So what you get? You get it is this simple as I'm writing e to the power z. Then z, though z is the function of x, y both, so I can write down del z by del x minus with respect to x it is yz. Then minus with respect to z it is your with respect to z xy del z by del x. Clear to all of you? It is clear to all of you? It is clear?
Yes, ma'am.
So what is the value of del z by del x? This implies del z by yz by e to the power z minus xy. Okay. Similarly, find out del z by del y. Tell me the result. Same. Only at the place of y it is x. Del z by del y. Tell me the result. Del z by del y.
Then minus y by x.
Huh? You'll get it is xz by e to the power z minus xy.
Yes, ma'am.
Are you getting or I'll do?
Got, ma'am.
I'll do. No? Or yes? Hmm? Can I do this one or not? What happened to you? I'm audible? I'm audible?
Yes, ma'am.
Yes, ma'am.
Can I do this one or not necessary to do?
Not necessary.
Not audible. Huh?
Not required, ma'am.
Okay. Then after 49, what is the number? 62. 62 or anything more?
Yes, ma'am. 62, 63, and then 81.
Huh?
62, then 63, then 81. Last year.
62.
Yes, ma'am.
Okay. Verify that the conclusion of Clarier's theorem. Verify that the conclusion of Clarier's theorem holds. That is, your question is u is equal to ln x plus 2y. U is equal to ln x plus 2y. What is your Clarier's theorem? U of xy is equal to u of ys. Is not it?
Yes, ma'am.
Do it. You are getting that value or not? Check it. u of x is equal to how much? U of x is equal to this one or not?
Yes, ma'am, getting the same value.
Yes, u of xy is equal to differentiate again with respect to y. What do we get? That is minus
Minus 2 by x plus 2 is whole square.
x plus 2y whole square. Is not it? Similarly, u of y is equal to that is 2 by x plus 2y. Is not it? U of yx differentiate with respect to x. What you get? You get minus 2 by x plus 2y whole square. So both are same, so satisfy the Clairaut's theorem. Then after this 62, which number? 62, then which number?
63, ma'am.
Okay. All of you have written this one, I am waiting. $63. Find the indicated partial derivatives. Find the indicated partial derivatives where your function x, y is equal to x to the power 4 y square minus x to the power 3y. Indicated partial derivative is your f(x), x, x and f(x), y, x. We have to find out the third order partial derivative here. Third order partial derivative. Here fx is equal to
4x
It
cube y
is
square minus 3x cube y.
fxx is equal to okay, then fxx is equal to 24x y square minus 6y. You have got it? Someone saying? You have got it? This value?
Yes, ma'am, got.
Okay. Then fx of y. Differentiate this one with respect to y, keeping x as constant because we are differentiating with respect to y. So what you get? You get 8x cube y minus 3x square. Okay. Again differentiate this one with respect to x. Here it is. So fxy x is equal to 24x square y minus 6x. Have you got?
Yes, ma'am.
Then after 63,
81.
81. Verify that the function z is equal to ln e to the power x plus e to the power y is a solution of the differential equation differential equation that is your del z by del x plus del z by del y is equal to 1 and del square z by del x square del square z by del y square minus del square z by del x del y is equal to square is equal to 0. Can you do? You are able to do yourself? First you find out del z by del x. Then del z by del y. Check that the addition is 1 or not. You take it. What is del z by del x?
E to the power x by e to the power x plus e to the power y.
Very good. And you get del z by del x is equal to e to the power x by e to the power x plus e to the power y. Similarly, del z by del y, what you get?
E to the power y by e to the power x plus e to the power y.
So if you are adding, you are getting 1 or not? If you are adding, then you are getting 1 or not? I am asking you.
Yes, ma'am.
So then del square, del by del z of, sorry, del by del x of del z by del x. Derivative with respect to x again. What you get? What you get? E to the power x, e to the power x plus e to the power y minus e to the power x, and the derivative of e to the power x, it is your e to the power x, so e to the power 2x divided by e to the power x plus e to the power y whole square. Clear? Clear? It is clear or not?
Yes, ma'am.
Okay. So we get e to the power x plus y divided by e to the power x plus e to the power y whole square. Is not it? This
Yes,
one I am
ma'am.
getting or not? So similarly, find out del z by del y. So del by del y of del z by del y. What do you get? What do you get? There also you will get e to the power x plus y and e to the power x plus e to the power y whole square. There also you will get this value. Clear? Then you find out del by, it is your del by del x of del z by del y. Del by del x of del z by del y. it is 0. Then we have the minus. First one it is 0. We are differentiating with respect to x. So it is 0. Then minus e to the power y. And the derivative of with respect to x del by, so it is your e to the power x. And this is 0 divided by e to the power x plus e to the power y whole square. Clear? Now put your value here. You are getting it is 0 or not, you check it. Put your value on the equation, you check it whether it satisfies your differential equation or not.
Ma'am, satisfies.
It satisfies. So it is over. Up to 81 over.
Yes, ma'am.
Then we start 14.4. We start 14.4. Any doubt you have here? Any doubt you have here?
No, ma'am.
No, ma'am.
So I'll start.
Yes, ma'am.
Okay.
Ma'am, in 81, there is del square z by del x square into del square z by del y square minus del square z by del x into del y.
You're not getting 0.
No, I'm confusing. That is multiply or.
Yes, multiply. Here it is. So if you multiply this one with this, what you are getting? Same value. I am getting it is your the value e to the power x plus y square. It is coming or not? E to the power x plus e to the power y whole to the power 4. Okay? Then minus the square of this. So I am getting this value. Same.
Same.
Okay?
Yes, ma'am.
Same I am getting. So now, (14.4) is your tangent planes and linear
Ma'am,
approximation.
Ma'am, this
Yes.
14.3 question number 67, ma'am, my answer isn't coming right.
What is 67? 14.3. 67 is given to you. Huh? You should what is the find the indicator partial derivative.
Ma'am, it's like awkward equation. My last
Okay, let me see. 67. Huh?
yes, ma'am.
14.3, question number 67. Let us check what is going. U is equal to e to the power r theta sin theta. What do you want? A cube ଦେଇଛି. Okay. Del cube u by del r square del theta. third order derivative. Okay, let us check whether we are getting it is satisfying or the answer you are not getting. What you say? The answer what is present in your book you are not getting.
Yes, ma'am.
67 answer is there. Okay, let us check. First you have to find out del u by del r. Okay. Del u by del r. It is what you get del u by del r, keeping this is as constant, so it is theta e to the power r theta, then sine theta. Is not it? Clear? It is clear or not?
Yes, ma'am.
Okay. Then del square u by, I'm taking that del r del theta. Okay. Del square u by. Means we are differentiating, that is your del by del theta, that is del u by del r. Okay. So it is the 3 theta. First one, what you get? E to the power r theta sine theta, then plus theta r e to the power r theta sine theta, then plus theta e to the power e to the power r theta, then it is your cos theta. It is okay?
Yes, ma'am. I'm done. Ma'am, I did a mistake here only. Done.
Here you have, I think you have missed it, done mistake.
Yes.
Then after doing this, now you can find out del square. Del by del r of del square u by del theta del r. Okay? Means to differentiate this with respect to r. So what you get? We get here theta e to the power r theta sine theta, then plus it is multiple of 2, then it is your theta, it is e to the power, sorry, theta into e to the power r theta sine theta, then plus theta square r e to the power r theta sine theta, plus here it is theta square e to the power r theta cos theta. Isn't that it? You are getting this value, this is your answer or not? This is your answer in your book? Reply me. What happened? You asked this question.
Yes, ma'am.
This is the answer?
Yes, ma'am.
Okay. Any doubt?
Ma'am.
Now 14.4. Tangent planes and linear approximation. Okay, first come to the tangent plane. So suppose a surface S in 3-dimensional. Suppose we have a surface here. It is a surface like this. It is, say it is here surface. Okay, it is S. Has the equation Z is equal to function of x, y, where the function f has first partial derivative exists. Let P be a point. It is P, it is x0, y0, and z0. The curve here you see C1, this is C1, passes through this point P. It is a curve here C1, it passes through the point C. Now we have another curve here, passes through this point C, say it is C2. So the tangent at this point for the curve C1, it is this one, it is visible, say it is T1. And at the point C2, that P0, at the point P, it is our, say, T2, the tangent. It is visible?
Yes, ma'am.
Okay. So the T1 and T2 are the tangent at the point P on the curve C1 and C2. If we have another curve, it is your like this, it is C1, C2, another curve you have, it is your like this here. Say I have another curve, say C. The tangent at this point here, say it is T. So like this, at this point, we have so many curves passes through this point, and the tangents are T1, T2, T, T3, T4, like that. So all the tangent that will form a plane that is called as the tangent plane. All these tangents at the point P, same point, form a plane that is called your tangent plane. All of you are clear?
Yes, ma'am.
This tangent, this tangent, this tangent, and if you have another all tangents, so they form a plane that is called your tangent plane. It is clear? I'm asking
Yes,
you, it is clear? Yes. So now the equation of the tangent plane, equation of the tangent plane at the point P, that is your x0, y0, z0. Okay? Is, you know, your equation is your A into x minus plane equation, B into y minus y0 plus C into z minus z0 equal to 0. Okay? At this point, equation of the tangent plane at this point is our this one. Tangent plane, it is the ABC, it is the component of the normal to the tangent plane. Okay? It is clear?
Yes, ma'am.
Yes, ma'am.
Now we can write down, it is in the form, this implies z minus z0 is equal to minus a by c x minus x0 plus b, sorry, it is minus b by c, it is y minus y0. I can write down, say it is equation 1. Okay, so it is equation 1. By setting y is equal to y0, y is equal to y0. Now the equation 1 became, sorry, first you consider this value as small a and this value as small b. Yes? What someone saying? Yes. Yes. Not audible to me clearly. What you are saying? Hmm? What you are saying? This is visible or not? This is visible or not? I am asking you. Why you are disturbing here? Someone disturbing here? Kuljit Singh, what happened to you? Kuljit. What happened to you?
Mistakenly, his mic was on. That's why the noise was coming.
Okay. So now, so I can write down minus a by c is equal to a and minus b by c is equal to b. Okay, so now your equation became z minus z0 is equal to a into x minus x0 plus b into y minus y0. Say it is 1, not don't say this is 1. Okay, so by setting y is equal to y0, y is equal to y0. So if you set y is equal to y0, what you get? We get the equation 1 now became z minus z0 is equal to a into x minus x0. So here it is the equation of the line. It is the equation of the line or not?
Yes, ma'am.
With the slope a, with the slope a, yes. So the slope a, it is the slope of the t1. It is your x minus x0. So slope of the a is the slope of the t1. That is equal to fx of x0, y0. Similarly, if we set x is equal to x0, then we get z minus z0 is equal to b into y minus y0. Okay? So there also we'll get, that is the value of b. B is the slope of the tangent t2. So b is equal to, we get that is function of y, x0, y0. So now by substituting this value here, now we get the equation of the tangent plane. Now the equation of the tangent plane is z minus z0 is equal to fx x0 y0 x minus x0 plus fy y minus y0, that is y minus, sorry, x0 y0 y minus y0. Okay, here it is. We have to remember for the equation of the tangent plane is this one, where z is the function of Yes. Clear? It is clear to all of you? It is clear to all of you? Kuljeet?
Yes, ma'am.
It is clear? I think you are not writing. You are writing?
Yes, ma'am.
Yes, ma'am.
I'm not asking to you. I'm asking to Kuljeet. Because when I ask, it is clear to Kuljeet, what then? Yes, ma'am. He said like that. Kuljeet, you are writing? Kuljeet, I am asking to you. Kuljeet. What happened to you? Let me see. Where is Kuljeet? Kuljeet, you are here? Kuljeet, you are here? Hmm. Kuljeet. Isi Vaibhav. Isi Vaibhav.
Yes, ma'am.
You are writing?
No, no, ma'am. Actually, I am outside, ma'am. Actually, I can't right now.
Huh? You are outside.
No, ma'am. Ma'am, today actually I have gone for vaccine, ma'am. So I returned to home and that's it.
You are not writing. Acha.
Yes, ma'am.
Raghav. Raghav. What happened to you? Over. Over or not?
Wait, ma'am.
Where wait?
Yes, ma'am.
Quick. I'll not give you any PDF. I'm writing everything. I'm doing all the problems also. I have no PDF. From the starting of the class, I said that you write down. Over?
Yes, ma'am.
Okay. Okay, now find the tangent plane. Example. Find the tangent plane to the elliptic paraboloid z is equal to 2x square plus y square. At the point 1, 1, 3. Do it yourself and tell me what is the value you are getting. You have your formula, and x0, y0, z0 is this one. You have to find out fx of xy, fy of x0, y0, sorry. x0, y0 is how much you have to find out at this point. And then you write down your equation of the tangent plane. You know your equation of the tangent plane is z minus z0 is equal to x0, y0, x minus x0 plus f of y, x0, y0, then it is y minus y0. Do it. Do it yourself. You are doing or not?
Yes, ma'am. 4x plus
Yes, ma'am.
2y.
Z is equal to?
Z is equal to 4x plus 2y minus 2.
Very good. This value, what you get here? You get it is 4. And this value we get it is 2.
Ma'am, minus 2. Minus 2. You have written minus 2.
Which one is minus 2?
Ma'am, 4x plus 2y. 4x plus 2y minus 2.
No, it is
Answer.
coming 3. You check it. I have given this same question, that 2x square plus y square. Yes, z is equal to. It is coming 3. Check it.
Yes, ma'am.
Next, linear approximation. Linear approximation. You see, if you look at your book, there is a figure there for this function, 3 types of figures there. If you see your book, there you find that if you zoom the curve, total curve, that will approximately equal to the tangent plane. That is approximately equal to the tangent plane. That is called your linear approximation. The linear approximation, write down, the linear approximation or the tangent plane approximation of a function at a b is your function of xy. Z is the function of xy. What you get here, this one. Function of xy is approximately equal to L of xy. Linear approximation is L of xy is equal to, what is the value of L of xy? L of xy is equal to function of AB plus fx of AB x minus x0 plus, this is your z0, you know it is. When I'm writing it is your, in the case of a this way, this is your z0. So it is fy of AB y minus y0. Sorry, y0 is not, it is here, I'm writing a, it is b. Okay. So this is the formula for the linear approximation. That is for the function of 2 variables. So for the function of 3 variables, in case of 3 variables, function of x, y, z is equal to, not equal to, it is approximately equal to L of x, y, z equal to function of a, b, c plus fx of a, b, c x minus a plus fy of a, b, c y minus b plus function of fz of a, b, c, that is z minus c. Last example, we find out that z is equal to 4x plus 2y minus 3. So here, linear approximation, when xy approaches to 1, 1, it is given to you point 1, 1. Is near to 1, 1. Then we called that is your linear approximation, that is of the function f at 1, 1. This example. What you get, L of xy or L of 1, 1. Linear approximation when xy approaches to 1, 1. That is your value. It is by combining all this, we are getting this value. Z is equal to, so we get here it is 1, 1, it is 4 plus 2 minus 3. So it is, we are getting it is 3. And you see it is linear approximation, it is 3. And the function of xy, it is your function of xy at 1, 1. What we are getting? We are getting here it is also 3. So yeah, I say that function of xy is approximately equal to xy. Say for the last example. Okay. Now, for this time, Okay, write down one statement of theorem statement. If the partial derivatives of statement of the theorem, if the partial derivative of fx and fy exist near AB, if the partial derivative exists near AB and are continuous at AB, then f is differentiable at AB. Then f is differentiable at AB. For example, so that function of xy is equal to x e to the power xy is differentiable at 1, 0. And find its linearization there. Then use it to approximate f of 1.1 minus 0.1. First, by using the definition, whether it is differentiable or not, check it. So you see fx of xy is equal to how much? It is your e to the power xy plus xy e to the power xy at the point 1, 0. Is how much it is coming? It is coming at the point 1, 0. It is coming
1.
So similarly, fx of xy, sorry, fy of xy, it is coming your x square e to the power xy at the point your 1, 0. Also 1. So this is exist. This is so it is differentiable. This function is differentiable. Okay, according to your definition. The next part we'll do. I think time is over. Next part, you try yourself, find out the linearization. Then after that, I'll explain you. I'll ask you what you get the linearization here, L of xy. What you get? Then after that, I'll explain you this part. Okay. So I'm going to stop here. Thank you to you all.
Thank you, ma'am.
Hello students, good afternoon to all of you.
Good afternoon, ma'am.
Yesterday we have done up to Holmes condition, right? Now it is vertex cover, and I'll discuss about minimum maximum etc. Vertex cover, as its name suggests, that is, it is the set of vertices and that is covering something, and that what is that something? Edges. Okay, a set of vertices that cover all the edges. Okay, any set of vertices if is the vertex set, subset of vertices, okay, that contains at least one endpoint of every edge. Clear?
Yes, ma'am.
For example, if you take A is containing at least one endpoint from every edge or not? Means A is covering all the edges or not? A is just covering this edge, right? Not covering this one, not covering this one. What about if I take A and B? Yes, it is. B is covering this edge, containing the endpoint of this edge, right? A is covering this edge. What about C? No, right? CD is not covered by A and B, right? So we need to take that set of vertices which covers every edge, all the edges. That means covering means that contains at least one endpoint from every edge, right? So if I take C again, also C, then C is covering C and D. Now the set of vertices A, B, C, this is covering all the edges, right? Yes, this is a vertex covered. What about if I take A and D, or B and D, or C and D, or just D? Is it covering all the edges? D is covering all the edges, right? A is covering this edge, and this edge, right? So this is covering all the edges. So this needs to be A and D or B and D. Okay. Q3, ABC. Okay, and all the vertices if you take it, that obviously will cover all the edges, right? These are the some vertex covers. Okay, out of which we want minimum vertex cover. Why? Suppose in we have 3 waves. Okay, and this is the meeting point. P is the meeting point. There is A to B, A to D we have a way, and or we can just say a rod. D to B we have a rod, and this right. So these are security guards A, B, C, and D. These are security guards. Okay. So how many minimum guard to require guard all these road? Yeah. How many minimum guard required to guard all these roads, all these ways? We want to minimize the resources. That's why how many D will work, right? We can guard this one, and this one, right? And if you take only A, it can just guard A to D, right? Only A, it can just guard A to D. And A and B, these two only, right? Not this one. Then either you can just take this one, or you can take this one, or this with this. So minimum what? One, that is D. Okay. So Q1 is the minimum vertex cover. Clear? Okay. Got it?
Yes, ma'am.
What about P2? How many vertices? vertex cover, minimum vertex cover. And this minimum vertex cover cardinality is denoted by beta of G. Okay? Minimum size or minimum cardinality of vertex cover is denoted by beta G. We had alpha dash G, right? And alpha G and beta G. We will also work with beta dash G. What are these? Alpha is the maximum. Alpha and alpha dash, these are the maximum. And beta dash, these are corresponding to minimum. And whenever dash is there, this is corresponding to edges, and alpha and beta without dash, these are corresponding to vertices. Now, alpha denotes the maximum cardinality of independent set, right? Cardinality of maximum independent set of vertices. That is, how many maximum independent vertices exist in any graph, that is denoted by alpha of G. Beta G is the minimum vertex cover. Okay, minimum vertices needed to cover all the edges. Clear? Got it? That is your beta G. And this one, alpha dash G, this is corresponding to maximum matching, and matching is independent edges. So this is your maximum number of independent edges. Okay, and beta dash will be your edge cover. That is minimum edges to cover all the vertices. Clear? Okay. Beta and beta dash minimum, alpha dash maximum, and dash means corresponding to edges, and these alpha and beta corresponding to vertices. Okay. Now corresponding to P2, what is alpha dash and beta? We have discovered this one, right? We have defined this one, right? Alpha, beta, and alpha dash. For P2, K2, tell me, for this graph, alpha dash, maximum matching, 1. Maximum matching cardinality set, 1 independent edge, right?
Yes, ma'am.
Alpha, how many independent vertices? Maximum 1, right? Beta, how many vertices can cover all the edges? How many minimum number of vertices can
1.
cover all the edges? 1. So beta is 1. Everything is 1. If I take this one, P3, then alpha dash will be 1.
2.
Maximum matching, just 1.
Ma'am, alpha dash would be 2, no?
Alpha dash is corresponding to edges, no?
Okay, ma'am. Okay.
Maximum edges. So if you take this edge you cannot take because of this common vertex, right? Independent edges.
Okay, ma'am.
And alpha means minimum vertex cover. How many vertices minimum needed to cover all the edges? Sorry, beta. This is beta. How many vertices, minimum number of vertices to cover all the edges?
3.
What about this one? If I take this one, then this cover this one. 1, na?
Common.
Vertex cover. Vertex cover is what? That contains at least 1 endpoints from every edge.
Okay, ma'am.
And the minimum is representing to minimum cardinality is beta. Okay, don't get confused between these. So beta is what? 1. Clear? If I take this vertex, this is covering both edges, right?
Yes, ma'am.
So that is beta. What about alpha? Alpha is corresponding to maximum independent set of vertices. How many independent vertices maximum? Yes?
2.
Taking it one at a time, yes, it is independent. Independent? Does there exist 2 independent vertices that which are not adjacent? Yes?
A and C.
A and C. Can we take 3? No, right? So For P2, sorry, P3, it will be 2, PZ1, 1. Clear? Got it? And for this one, example 15, can you tell me alpha test, alpha and beta? If you take all the vertices, obviously, all the vertices are covering every edge, but we want to minimize it. So minimum vertex covered cardinality will be your beta. Yes. Minimum number of vertices to cover all the edges. And covering means that contains at least one endpoint from every edge. Yes.
And
If we take A, B, C, D, E, F, all are covering all the edges, right? Am I double? If we take B, C, A, these are also covering all the edges. Is it?
Ma'am, B isn't doing.
Yes.
Ma'am, B is not covering all the vertices.
Not at a time. A comma B comma C. The set I am just saying. These are covering all the edges. C is covering this vertex. B is covering sorry, this edge. The vertex A is covering all these, right? And also, if you
C, B
take
are cut off.
yeah,
Ma'am, C and B is not covering the AF, sorry, E2 edge. Then
yes. So that's why we cannot take these two, right? This
yes,
is
ma'am.
not an edge covered.
Yes, ma'am.
And these three covering. These three covering. Any one vertex not covering. Any two vertexes there? If you take A and
A
B,
and D are covering everything.
yeah, every edge. So minimum is this, right?
Yes, ma'am.
So beta will be 2. Clear? And the
Yes, ma'am.
vertex cover is A comma D. Is that clear, everyone?
Yes, ma'am.
Yeah. Now maximum matching. Can you find maximum matching cardinality? That is alpha test. These are three vertices over here, three vertices here. Can you find three edges which are independent? Three edges which are independent. Yes? Does that exist? Any three edges which are independent? Any matching containing three edges? Yes? Tell me. Hmm? That does not exist, right? If you take this one, you cannot take this, you cannot take this, right? And you can take this edge, then you cannot take this one. So two edges, either this or this, this or this, this or this, right? Or this or this. Two edges are forming maximum matching, right? Anything you can take it, these two, E1, E2, or these two, or you can take E1 with this edge, or you can take this edge with E2. But the maximum cardinality is what? 2. Clear? And anyways, whenever you have two vertex covered, that is beta is 2, there cannot be more than 2, that is more than 2 number of edges which are independent, right? हर edge तो यहाँ से ही निकल रही है, right? Every edge is incident with either this one or this one, right? So at most there can be how many? 2. 2 number of edges, okay? Which are independent. The maximum cardinality is what? 2, na? Beta is 2 and alpha dash is also 2. Clear? Got it? Am I audible? Hello? Hello?
Yes, ma'am.
Okay. What about this P5? Sorry, C5. Yeah, here you can also talk about alpha, beta, alpha also, right? Beta we have done 2. Alpha dash we have done, that is also 2. What about alpha? How many independent vertices maximum? These two and these two, right? 4. 4 independent vertices set. Okay, maximum. Yeah, anyways, for C5, find the alpha, beta, and alpha dash. Maximum independent vertices. Maximum number of independent vertices. How many exist? Yes.
2.
2. You can take this one. These two you cannot take. You can take this one. And if you don't want to take this one, you can take this one. So maximum is 2 only, right? That is your alpha. Alpha is 2. What about alpha dash? Maximum edges, independent edges. That is matching. Maximum matching. Alpha dash. You can take this edge. Cannot take this edge. Cannot take this edge. Right? Then you can take this one or this one. Right? These two we have taken. So maximum is what? 2. This is also 2. This is also 2. Right? What about beta? How many vertices? Minimum number of vertices to cover all the edges. Yes? How many minimum number of vertices to cover all the edges? Can you cover by one vertex all the edges?
No, ma'am. 3.
No. This is covering these two. Then you can take this edge. This vertex. This is covering these two. This one is left, right? So either you can take this one or this one. The minimum, how many? 3.
3.
This is 3. This is 2. This is 2. Okay?
Ma'am, beta part again.
Yeah?
ma'am, beta out of 3.
Not audible clearly.
Beta 3, ma'am.
Beta again.
Yes, ma'am.
Okay. So how many vertices we need to cover every edge? One is if you take all the vertices, right? But we want to minimize it. Okay.
Yes, ma'am.
So this is covering both. Okay, both edges. So no need to take this one, no need to take this one, because these are covered by this one, right? Then for these two edges, you can take this one. These two edges are covered by this one, right? Now this edge is left. For this one, you can take either of these two, right? Clear?
Yes, ma'am. Clear.
Because this edge is finally left, that's why we have to take third one. Otherwise, no. In case of, for example, C4, we can take these opposite vertices. This is covering both the edges, and this is also covering the remaining two edges. No need to take any other, right? But here we need to take the one more vertex to cover the left behind edge. Okay.
Yes, ma'am.
Now, at this point, I told you that maximum matching. Whatever. Here we have A and B. This is your minimum vertex cover set, right? So, can the minimum vertex cover, or you can just say, can a vertex, any vertex, cover any two edges of matching? In any vertex, can a vertex cover two edges of matching? That is,
No, ma'am.
cannot be, right? Otherwise, this will be common. This vertex will be common. Okay.
Then it
This
will-
cannot occur that this one E1 and E2, these both are part of matching, right? That is, any one vertex cannot cover two edges, or you can just say it can cover at most one edge, right? Clear? So what we have here, there is no vertex can cover two edges of a matching. That's why the size of every vertex covered will be at least the size of matching, right? See, कम से कम उतने तो होनी चाहिए, right? So matching, maximum matching is given by, maximum matching size is given by alpha dash, and we know that no vertex can cover any two edges of this size, this matching. Okay. That's why at least इतने number of vertices तो होने चाहिए ना to cover all the edges of this one, right? Okay. So always beta is greater than equal to alpha dash. Okay. This is your minimum vertex covered, and this is your maximum matching. Read out. And for any bipartite graph, this is for any graph, okay? For any bipartite graph, tell me. See, in any general graph, it was beta c. Beta was greater than alpha. Okay. Here we have strictly greater than. Can we have equal? Yes. Here. So in any bipartite graph, you have equal. Equality.